Hello guys. So I hope you all are doing well. So today we will practice some previous year questions of BHEL. BHEL means what? Bharat Heavy Electronics Limited. Okay. So if you want to crack the BHEL engineer training exam or supervision training exam, so the today's lecture is very helpful. So today's lecture will be very helpful for you. So let's start it, man. Okay. So today's target is BHEL. BHEL. Okay. This is a PSU. This is a PSU. That means public sector undertaking. Okay. So this job is very good. Okay. PSU, its salary hike is also very good. Okay. If you cracked it, then I'm telling you, your life will be set because this is a very good company or very good organization. From there you will learn so many industrial knowledge, okay, so many practical knowledges. So if you ever get a chance to work there in BHEL, then I'm telling you it will be life changing for you. It will be life changing for you. You will gain to great practical knowledges from that industry, because mainly BHEL is a manufacturing company or manufacturing organization. There the manufacturing part is main, means the subject we will study in coming lectures, the manufacturing process or manufacturing engineering. So that subject's application is vast in BHEL. Okay, so if you want to work in BHEL, then if you want to crack the BHEL's interview, then you have to know the manufacturing processes very deeply. Okay, so then you can crack the BHEL interview and work there. Okay, so let's start it, man. Okay, so the first question is, select the thermodynamic defect. Select the thermodynamic defect from the options given below. The option A is line defect, option B is point defect, and the option C is area defect. Okay, and the option D, volume defect. Okay, select the thermodynamic defect from the options given below. Okay, so this is a material science question. This is a material science question. Okay, so we haven't studied the material science, so this question is not relevant for our lectures, but we are doing this because it is helpful for you. Okay, so select the thermodynamic defect from the options given below. Okay, line defect, the point defect, and the area defect, the volume defect. Okay, we know that atoms and molecules of a material are vibrating temperature. So if we put heat into the material, then the atom of it will move from their initial position. Okay, suppose a material, okay, suppose this is a material. Okay, I'm drawing here. Okay, suppose solution. Okay, firstly you have to note down this question, okay, because there's probability. So we are solving P by Q, so you have to solve P by Q very deeply or very rapid manner, so then you can crack these competitive exams. Okay, so yeah, suppose a material, suppose this is a material, okay. Here is one atom, the second atom. There's lots of atoms are present in this building, okay. In room temperature, we all know that these atoms vibrates, okay. This atoms vibrates, and when we put extra heat into that material, when we put extra heat into this material, then the atoms of these materials start moving from their initial position. Suppose this is atom 1, this is atom 2, and this is atom number 3, okay. Suppose this is a material, suppose this atom 1 goes to atom 2, no sorry, the second position. Suppose here, and the atom 2 goes to this position, and the atom 3 goes this position, and other atoms like this 4, and this is 5, this is 6, this is 7, this is 8, this is 9. Suppose this atom like 8, okay, this is atom number 5, this is atom number let's say what, 4, okay, no, not 4, this is suppose 7, so this is suppose 7. So after putting heat these atoms of this material move from their initial position, and this kind of defects, like the atom is moving from its initial position to another position, okay, to its initial position to another position. So this is how some kind of defects is occurring in this material, okay. So this kind of defects we called as point defect, okay. So this kind of defects we called as point defect, okay. So I hope you all understood, okay. I am telling you again. Suppose this is a material, here the 1 2 3 4 5 6, these are all atoms, okay. These all atoms vibrates in room temperature, okay. Room temperature is not absolute zero temperature. We have studied in previous classes that absolute zero temperature is not the room temperature, okay. So some kind of temperature is always present in our atmosphere or in our surroundings, okay. So that heat or that energy vibrates these atoms, but when we put extra heat into it, suppose this is it, suppose when we put extra heat into it, these atoms start vibrating much more than when it vibrates in the room temperature, okay. So it's vibrating, and these atoms move from the initial position to another position, and this is how a defect is occurred, which is called point defect. Like this, like an atom is moving from its one point to another point, and the another atom is moving from its one point to another point. So this is how defect occurs, and this defect is called point defect. Okay, this defect is called what? Point defect. Okay, I hope you all understood. This is a very easy concept. I don't think so that you will feel trouble to understand this concept. I hope you all understood. So let's move to the next question. Okay, so let's go to the next question. So the next question is, a solid circular shaft of length shaft of length 4 meter is to transmit 3.5 megawatt at 200 rpm if permissible shear stress is 50 MPa. 50 megapascal. MPa's full form is 50 megapascal. The radius of the shaft is, okay, the radius of the shaft is option A 1.286 mm, C point 0.1286 mm, 0.1286 mm. Okay, this is 12.86 mm. 1.86 mm. Okay. So this is a question. A solid circular shaft of length 4 meter is to transmit. A solid circular shaft of length 4 meter is to transmit 3.5 megawatt at 200 rpm. If permissible shear stress is 50 MPa, the radius of the shaft is what? Okay. Permissible shear stress is 50 MPa. The radius of the shaft is what? So this is a SOM question. Okay. The one thing I need to tell you is SOM is a very important chapter, man. I'm telling you, SOM is a very important chapter for this kind of competitive exams. Okay, like BHEL, HPCL, IOCL, and all other PSU's exams, and also like PARC and GATE. So strength of material is a high weighted subject. Okay, so we will make lectures. I will surely make a lecture on this subject. Okay, so then we will together practice and learn the strength of material. Okay, so now we will solve this question. Okay, so first we have to, okay, okay guys, do one thing, note it down, then we will solve. Note it down first. I'm giving 1 minute. Okay, I hope you guys noted. Okay, so now solve it. Okay, here the power, the value of power means the solid circular shaft of length 4 meter is to transmit 3.5 megawatt. So what is so megawatt is whose unit? Megawatt is the unit of power. Megawatt is the unit of power. So P is 3.5 megawatt means power. Okay, P is 3.5 megawatt. Okay, M means at 200 RPM. RPM, the full form of RPM is rotation per minute. Okay, a solid circular shaft of length 4 meter, a solid circular shaft of length 4 meter is to transmit 3.5 megawatt power at 200 RPM. So the N 200 RPM means the rotational, the rate of rotation. The rate of rotation is 200. So we will denote it with N. So we will denote it with N. Okay. Then the permissible shear stress, the formula of shear, the value of shear stress. Shear stress we denote with this. Okay. Shear stress we denote with this. The value of shear stress is 50 MPa means the megapascal. The megapascal is the value of stress or any kind of stress like here, here shear stress is given. Okay, so let's go to the formula. Okay, the one thing I want to tell you, I won't solve here because you have to solve it. If there is some difficult questions, then definitely I will solve, but the easy questions I will not solve. Okay, P is the power which is transmitted. Okay, the power which is transmitted here is 2 pi mt. Okay, by 60. 60 means 60 denotes the minute, 1 minute. Okay, rotation per minute, where rotation per minute, minute means M means minute, M means minute. So here 60 denotes the 1 minute. Okay, 60 denotes the 1 minute, and N is number of turns, T is torque, and pi, you all know pi, and P means power. This is the formula of power. Okay, the power which is transmitting. Okay, this is the number of turns. Okay, this is the number of turns. Okay, so this is torque. This is torque, this is number of turns, and this is power, and this is denotes of 1 minute. Okay, so is the formula of power. So the induced shear stress, we have to find out the induced shear stress. Okay, induced shear stress. So then the formula will, okay, I hope you noted it down. So the formula will, this is the formula of power. Here from this formula we are coming to this formula, which is this one. Induced torque, induced torque, induced stress is equal to 16T upon pi d cube. Okay, pi d cube. So this formula, through this formula, you can solve this question. You can solve this question. Okay. So I'm telling you, firstly you have to understand the question, then you can solve. Okay. So my try is, so the, I try to to understand or to solve or to break the questions part by part, so that you can understand the question well, then so that you can solve it. Okay. So that's my strategy. I break every part of this question so that we can all understand and then we can solve. Okay. Okay. So again a SOM question. I'm telling you, SOM is a very important thing. Like SOM is, SOM is your third girlfriend. Like, okay, the first girlfriend is your I'm telling you, the subject manufacturing engineering. The first girlfriend will be your manufacturing engineering. Second subject will be what, thermodynamics. I'm telling you, which subject? Yeah, refrigeration and air conditioning. Refrigeration and air conditioning plays a very important role. Okay, in GATE. And the third subject is the strength of material. Okay, third subject is this is the strength of material. So your third girlfriend is strength of material. Okay. True stress. Experiment. True stress experiment by a material. True stress experience by a experiment by a material is then the engineering stress at a given load. Engineering stress at a given load. Option A, lower. B, higher. And C, equal. And the D is higher on lower. So these are the options. So these are the options. You have to, okay, note it down. I am giving you 1 minute. Okay, note it down. Okay, so I hope you all guys have noted it. So let's move to the solution part. Let's move to the solution part. Okay, we have not moved types. Okay, so the solution is omega t omega f into 1 plus strain E. Okay, so this is a formula. Here this denotes the true stress. This is engineering stress. Engineering stress. Okay, one thing you have to know, that this sign and this sign denotes stress and this sign denotes strain. Okay, this is what this is engineering strain. This is engineering strain. Engineering strain. This is engineering strain. Okay, and here the plus sign. So let's see. See, I am breaking the formula in every single part. Okay, so please here, I am giving some so much effort here. Please like and share and subscribe here. That's all I would say. Please like, share. I'm giving so much of effort here. So give me just a like or even subscribe. Okay. So this plus sign denotes for tension. For tension, and this also this for compression. Okay, plus sign for tension and minus sign for compression. This is a minus sign for compression. Okay, so this formula we will use for our question. Okay, so the formula will be, the actual formula will be, so note it down first. Okay, so you have to note it down first. Pause the video and note it down. Okay, done? Okay. Okay, so this formula we will use. Torque max, maximum torque is equal to T into R, which is D by 2, T into R, pi by 32 into D to the power 4. Okay, here 16T and pi dq. Done? This is very interesting. Okay, this formula will is for this formula is for this question. Okay, the torque max. Yeah, by putting torque. Oh, not, something is wrong. Okay, the option will be B. Yeah. What I'm doing, man? Not. These are some extensional formulas. Okay. So this formula, let's see. This formula is the solving part of the question. Okay. This formula like is equal to the previous formula. Okay. 1 plus, okay, this is true stress, this is engineering stress, and this is engineering strain. Okay, so true stress, here we say the true stress experienced by material is dash than the engineering stress at a given load, is dash than the engineering stress at a given load. So this is the true stress and this is the engineering stress. So which one is higher? Which one is higher, true stress or engineering stress? Obviously true stress. True stress is higher because true stress is equal to engineering stress into 1 plus engineering strain. Okay, 1 plus engineering stress. So true stress is definitely higher. Okay, thank you so much for today's class. I hope you all enjoyed or learned hope you always enjoyed. Thank you so much. Thank you for joining in. Bye bye.